moisture control is all year round. We have these birds, they're drinking the water. They are a primary source of the water in the house. And so, when they drink, and right now, at least I'm going to go with broilers for the moment. For every pound of feed they eat, they're going to drink 1.8 pounds of water, and it comes out to be about a quart. And then out of that, they retain only about 20%. So the other 80% is going into the environment, going onto the floor, through manure, excretions. And so, that is moisture we have to remove.
Welcome to the Poultry Podcast Show. Today, I'm here with Dr. Ryan Fairchild. Welcome.
Hey there. Glad to be here.
We are going to chat about a few things related to management of poultry buildings as we move through the seasons. But first, I want to hear, how did you get to your current role? How did you get into chickens? Did you fall into them, or has it been a lifelong passion?
Okay, well, I've been here at the University of Georgia for 25 years. And when I started my college trek, I went to NC State, where I double majored in animal science and poultry science. My family had a broiler house with Holly Farms that my grandfather had. And then my grandmother worked for Holly Farms, which later became Tyson. And my dad was there as well. So, I've been kind of around poultry my whole life. And so in my senior year, I got a job in a turkey physiology lab. And prior to that, I had no clue what grad school was. I just thought they were grad teaching assistants. And as I got in the lab, I kind of figured out that, hey, it opened up a new world for me, because I was pre-vet up until that point, and it started opening up some new options for me. And so kind of did a little switcheroo, did a little diversion, a pivot on my career path there, and decided to do a master's in physiology with Dr. Christensen there at NC State, working in turkeys. And he being one of the experts in the world on that, I ended up staying for my PhD as well.
Yeah.
And then got done, thought I'd be in turkeys forever. But when I got done, started looking around for jobs, UGA made the offer first, and I've been with broilers ever since.
It sounds like it runs in the family, though, so it's the space you're supposed to be.
The nice thing is I still get out to see some turkey farms and do some visits and work with some of the turkey companies on the side. So when I've got spare time, I still get my fingers into it a little bit on the turkey side. Yeah. And the nice thing is a lot of the work that I do kind of grows across all of our poultry operations, turkey, broilers, layers. Kind of fits a lot of quail.
Yeah. Oh, quail. Love that. It's flexibility in your job. You can never be bored.
Nope.
Feed formulation software is stuck in the past. Most tools haven't evolved beyond basic least cost optimization. A Diet Forge changes that. It's an AI-powered platform with nonlinear ingredient modeling for enzymes and additives, cost per gain and maximum profit optimization, and real-time collaboration like Google Docs for nutrition. Every recommendation is grounded in world-class research, built for modern nutritionists who need more than legacy desktop software can deliver. Work seamlessly with your team and optimize the way modern operations demand. Try dietforge.ai free today. Feed formulation, finally modernized.
So I want to hear a little bit about your experience, your research, and just kind of the general field, the key things that we need to think about as we move between seasons, especially from warm to cold, like most of the U.S. is experiencing now. So what are some management tips for cold weather for poultry houses?
Well, I think when people think of poultry houses, a couple of things come to mind, and that is air quality and litter quality. And the two are kind of connected together, because if we start to see litter quality deteriorate, it adds to more ammonia in the house, and it affects our air quality. And, from a litter quality standpoint, there's also the impact that it has on bird performance, from thermal regulation to more bacterial challenges, coxy challenges, as well as the impact it has on leg health and foot pad health as well. So there's this big. It kind of affects all the hops topics for poultry production. The performance, the health, and the welfare side. So that's why we try to optimize on that. So those are my two biggies that I would say we do that with. And of course, the other thing that comes to mind with cold weather would be energy conservation. Because most of our farms in the U.S. are heating with either natural gas or propane, and so that's an expense coming out of most usually it's out of the growers' pockets. There's some companies that cover that, but it is an expense. So we need to try to think of how do we maintain that optimum environment with minimizing our fuel usage. And so one of the things that we've focused on over the years has been looking at energy conservation type applications that would reduce energy consumption. And so when we did that, we also found that we would actually end up with a better environment for the birds. It was a nice win-win type thing. I'm saving gas, but hey, a better environment for my birds, so maybe they'll grow better and they'll have a higher livability, and we end up with more pounds being marketed at the end.
So what can you tell me if we just start with some of the litter moisture and the circle that is humidity and ventilation management? So what are some of the key things to think about? It's such a difficult thing when the weather changes.
Well, and it's interesting because it's not just a cold weather problem. It's moisture control is all year round. We have these birds, they're drinking the water. They are a primary source of the water in the house. And so, when they drink, and right now, at least I'm going to go with broilers for the moment. For every pound of feed they eat, they're going to drink 1.8 pounds of water, and it comes out to be about a quart. And then out of that, they retain only about 20%. So the other 80% is going into the environment, going onto the floor, through manure excretions. And so, that is moisture we have to remove.
Sure.
And so what we've done is we try to focus on that. We kind of use our water usage measurements from the water meter to kind of guide our ventilation rate. So that's one way to do it. The other way is just to monitor relative humidity. I think that's the simplest way. So you have these kind of checks and balances in place. I could look at my water meter, and as that water meter, because that consumption increases, we know that we need to be increasing ventilation rate. As humidity increases, I need to be increasing my minimum ventilation rates. And for a lot of people, sometimes I guess they don't quite understand the principles behind that air temperature and moisture holding capacity of the air. But cool to cold weather is actually easier to dry houses than it is in the summertime. Because you start looking at that temperature differential from inside to outside. As we bring that cool air in, it might be a rainy, cold day, 100% relative humidity outside. But we bring that air in and we move it up and warm it up before it comes into contact with the birds and the floor. We can reduce that relative humidity down to 25%.
Oh, sure.
And so on a cold, rainy day, I can still remove moisture from the house. Now you go into hot weather and your temperature differential from inside to outside gets smaller. And so, it might be 80 degrees outside and it's 84 degrees inside, or 85 degrees inside, or 90 degrees. You don't have that big temperature differential, so you're not heating up. So you don't remove as much moisture per CFM. And so, or cubic feet per minute when the fans are running.
Sure.
But what we have to do is we just have to run more CFM through the house, because that temperature differential is smaller. We have to run. So there's this understanding of how it's a little bit of physics, to understanding. If you understand that standpoint, you've got minimum ventilation and moisture control. You know the basic principle to that and can apply that to your operation.
Yeah. So does this work across building types, or are there some that make this more efficient? I mean, we've got, for example, hen houses with just cages in the way if it's a cage operation. Is that still the same principle?
Principles still apply. How they're implemented is going to be a little bit different.
Sure.
But you have to think about layer cages, totally different little dynamic there than it would be in a turkey house or a broiler house or even some quail houses where they're on the floor and they're running on a bedding material, because in a lot of our houses nowadays, we have the manure belts. And so they're removing a lot of that moisture out of the house whenever they run that manure. So it changes our ventilation, but a lot of times then again, we've got a lot more birds in the house. And so we still have to, again, going back to what I said earlier, all the principles apply across all of those production systems. How we implement it and apply it is going to differ. I do it differently for layers than I would for turkeys. And turkeys is going to be more similar to broilers and vice versa.
Yeah. So it seems like the most important part of at least the humidity and moisture management is understanding that balance based on the temperature outside, inside, and then ventilation, running fans.
Yeah, I think it's important, because what do people do when it starts raining outside? We've had 4 days of rain. It's been rainy, rainy, rainy. What do people tend to do? They're going to cut back on their ventilation rate.
Oh, yeah. Yeah.
Because people are thinking, I'm bringing in moisture. Well, not really. If we're heating that air up, and usually in cool and cold weather, the house is going to be warmer by several degrees than the outside. And so as we warm that air up, we can increase the moisture holding capacity, and it helps to remove the moisture from the house on a cold, rainy day. So technically on a rainy day, you'd want to increase your ventilation rate to actually help remove some of that moisture if it was a cool, rainy day.
Yeah. So it sounds like your fan setup and your circulating air systems are key.
They are. And that's interesting you bring that up, was on the circulation fan systems. Because that was some of the work that, Mike Zarek and I did years ago when I first started here at UGA. We started looking at some of these circulation fan systems with basically 2 or 3 objectives in mind. One was to break up stratification in the house, warm air at the ceiling, cooler air at the floor. And so we could break up that vertical stratification. We could move air from the warmer parts of the house to the cooler parts of the house with a horizontal circulation fan system. And that gave us more uniform temperatures. And so in doing that, by moving that air to the cooler parts, those heat zones ran less. We had energy conservation.
Yeah.
So we got energy conservation, we had more uniform temperatures, and we broke up the stratification, took advantage of that air that we paid to heat up at the ceiling. So then, skip ahead about 10 years, and, we're getting more and more, there's more and more challenges from a moisture standpoint on the houses. And so we saw that what we need to do is we need to remove more moisture. We need to be more aggressive with getting the moisture out of the house, out of that litter.
Yeah.
And trying to be more aggressive, keeping our floor dry. And so we added another objective to our circulation fan system, and that was dry litter, helping dry litter. And the thing is, we can't do it with the old style fans we were using, because at the time we were just using these 1/15 horsepower basket fans. And we'd probably only be mixing maybe 10% of the house air volume. Well, that's not enough to really move air along the floor to help remove that moisture. So now we're looking at increasing that using panel fans that are moving more air, 5,000 plus CFM, and getting a better air movement at floor level to help remove that moisture.
Yeah.
And so what we recommend people do is we try to say, monitor your relative humidity. You can look at your water meter, like we talked earlier, and as that water increases, hey, if my water consumption's doubled from day 10 to day 15, then my ventilation rate needs to basically double.
Yeah,
I need to go from wherever I'm standing at. But Another simple way of doing it is just monitoring relative humidity. And what we'd like to see people do is just keep it below 60%. If I had to give them a range, I'd say between 40 and 60. That'd be your sweet spot.
So do the current control panels in the houses, do they have enough sensors to measure relative humidity, or is this something that you kind of need to set up along the house itself?
All the controllers I'm aware of do have the option for a humidity sensor, a relative humidity sensor.
Yeah.
It's not something that's included in a lot of standard packages. So, most people are still going to focus on that. And it's not like we're going to run the controller off. I'm not going to run my fan off of that humidity sensor. What I want to do is I just want to know what my humidity is in the house. I like to walk in there, I see that controller and it's saying, oh, it's 65, 70%. We need to increase ventilation rate that day. If I walk in and it's running around 55, 58%, I'm going to say, okay, I'm okay. I can wait another day. And so what I'm doing is I'm using it as a management tool to decide how I am going to manually manage the settings in my controller. And the reason we do that is because, you turn that controller loose, and depending on what kind of humidity sensor you have, and what the accuracy is it plus or minus 5%? Is it 2.5%? Is it 10%? The bigger that range gets, the more gas that could be burned because of higher ventilation rates.
Right. So then you go to the other side.
They've got to find that sweet spot. That's why I tend to manually adjust them rather than just turning the controller loose with the humidity sensor. I go in and measure it and make adjustments based off of what my house humidity is. And usually we'd like to see people measure that early in the morning because you're coming off the nighttime. If you're going to have a low ventilation rate, it's going to be at night typically. And you want to see what those conditions are first thing in the morning so you can make an adjustment based off that house environment.
Yeah. Personalize it, individualize it.
Otherwise, you got to go in about 2 or 3 a.m. and really get a good estimate of how the house looks.
Well, if you've got insomnia, maybe that's the thing that someone wants to do. So you mentioned some of the circulating fan and other conditions that impact the litter moisture, and the humidity, of course, kind of ties into that. So are there any changes that you suggest other than fans to impact litter moisture? Is this something we just pay attention to, or we react to it, or can you proactively help?
Well, I don't want to be reactive. You want to stay ahead. By controlling that relative humidity, you are being proactive. Otherwise, if you wait till your litter conditions change and you say, oh, my litter is starting to get moist, it's starting to, some people say slick over, or if it's already starting to cake, well, that doesn't tell you how you've been doing today on your ventilation rate and litter house moisture management. It tells us how you did the last 2 or 3 weeks.
Yes.
And so by controlling that relative humidity and I'm going to continue to use the word aggressive because we want to stay on top of this, from day one of trying to make sure we're doing a moisture balance. Any moisture they're adding to the house, we want to be removing it from the house. And our data has shown that, if we keep that relative humidity below 60% in that 40 to 60% range, if we do that, then house conditions will fall in line. That's kind of that optimum zone right there.
Are there any other major things that need to be thought about? Just outside of the hugely important humidity and temperature and ventilation guidelines.
I would think 2 things come to mind. One would be drinker management.
Sure.
Drinker height, water pressure. Both of those could lead to more water condition, more water wastage in the house. And all that's, if it doesn't go in the bird, it's going to go on the floor. And so that's one. And then the other, I would say, is utilizing migration fences.
Oh, sure.
Keeping those birds evenly distributed.
Yeah.
So that, because your floor, your bedding material, is going to be, it's kind of like your sponge, right? It's a large part of that bedding material's function is to help absorb that moisture and kind of, have somewhere for that moisture to go. but a good bedding material, you should be able to dry it out as well. And so by making sure you've got the right litter depth and keeping those birds evenly distributed, because if you get 60% of the birds in the front and only 40% in the back, or all your birds are staying near the sidewalls for whatever reason, those areas are going to tend to get wet or slick over more than the other areas would be. So that's a couple other management concepts that I would employ and try to stay on top of. I consider that kind of low-hanging fruit, right? I mean, it's something we should be doing, keeping those birds evenly spread out, because, again, we've calculated how much feeder space we need and how much drinker space we need. And if you end up with 60% of the birds in the front and 40% in the back, well, now there's more competition for food and water in the front.
Yeah,
and
you're in trouble.
Yeah.
I don't know if this data exists. It just came to mind, though. Do you have any data, or others have any, that show that some of these bedding types, materials, or combinations, because they're being reused for a period of time, are more, I don't know what the right word is, they can take the drying and the wetting process, they're more resilient, they can kind of maintain that moisture holding capacity? Or is it just, you got to control the bedding and you're the determinant?
Great question. So there are a couple of, there's at least two, there might be three, actually I can think of three off the top of my head, really good papers that are in the scientific literature on different bedding material types and, what they did. And one of them, we published, there was one out of Auburn, there's one out of Australia. I mean, those are the three that come to mind right off the top of my head. And they showed that, these different bedding materials, sawdust, pine shavings, used shavings, peanut hulls, rice hulls, paper products, just all these different bedding materials people have used. What we did is we actually saturated those. We weighed out like 100 grams or so of material, saturated it by soaking it in there to see exactly what their moisture holding capacity was. Then we put it in a drying oven, and we went in and measured it at increments to see how quickly we could dry it out. And so, of course, when you start looking at things like that, particle size becomes a big.
Oh, right.
Yeah, it becomes interesting because a lot of people say, we want pine shavings. And I'm like, well, I like pine shavings too, but I like it to be almost what I would consider to be double ground. I don't want the big fluffy ones that rabbit people and horse people might like. I want the stuff that's got smaller particle size that has a larger surface area for moisture removal, drying ability.
Yeah.
You get to peanut hulls or rice hulls. Great. They can be great bedding materials, but we know they don't absorb moisture very well. So what do we have to do? We have to put more of it in the house. Instead of going with, 4 inches, we need maybe 5 or 6 inches.
Yeah.
So once again, it's the same thing like with the temperature and the relative humidity control. Once you understand the concept and the principles, you just got to understand how to apply that in the field to get those optimal results.
Well, it sounds like such an interesting topic because each house could have slightly different required controls that make it optimal. And the one next door just might be slightly different.
Yeah. Well, there's other things that can happen too, right? I mean, it's not unusual to go onto a 6-house farm and broilers or even with turkeys, you might have 2 or 3 houses and you walk in there and one house has got something going on, some kind of challenge, health challenge or something. And, when birds, just like other animals, when birds have some kind of health challenge, a lot of times the food isn't digested well. Their intestine does not absorb as much of the moisture as it should, the water. And so we end up with wetter manure.
Yeah.
That can be a factor. And that's, again, it kind of shows up in the relative humidity when you do that, because if you got all that wet manure going out into the environment, and as it gets evaporated into the air, your humidity goes up. And so again, that's why I reemphasize why we need to be measuring relative humidity. And if we don't have a humidity sensor in the house that's tied to the controller, at least have something handheld.
Oh, sure. Yeah.
A lot of times I tell people at least have it in one house, that way hopefully all three of your houses or all your houses are running similarly, and at least measure it in at least one. But I do carry my portable one with me when I'm out in the field.
Oh, yeah. I totally understand why. Are there any major points just regarding this topic that we didn't touch on, or anything that you want to emphasize, like the Cliff's Notes version of what we chatted with?
Well, we talked about the moisture control, which is mostly going to be done by keeping that relative humidity between that 40 to 60% range. We talked about the drinker management. That's pretty low hanging fruit there. The bird distribution, and we talked about the circulation fans. And so the thing about the circulation fans, I kind of just really briefly kicked in there and told you kind of, hey, we were moving away from those small 1/15 horsepower, 18-inch fans, and we're going to a 24-inch panel fan that's moving, 5,000 or more CFM. And that's the big change. Just putting circulations in the house isn't going to give you dryer litter. You got to choose the right. You got to choose the right fan. And so, drier houses. I always tell people, dryer houses are going to cost more because you're going to have to ventilate a little bit more to control that relative humidity. You're going to have to, use the circulation fans. I mean, it's a little bit more expensive, but I'm hoping, and what we're seeing is that in the end, we get better performance from the birds, better livability, better paw quality. So hopefully there's a return on that investment.
It's time for our famous three.
Every day you're up before the sun, caring for your animals, your land, and your livelihood. You don't cut corners, and neither do we. At Signify Animal Lighting, we use light as a tool, backed by science to support growth, comfort, and performance. We've spent decades studying how animals respond to light, how it guides their day, reduces stress, and supports the healthy growth you depend on. We turn that knowledge into lighting systems that help you create the right environment from sunrise to sundown. Better light, better animals. Better results with Signify.
Yeah, pays off a little bit. Are there any resources or places people can go to learn more about this?
Probably the most of our work has been summarized and published in our UGA poultry housing tips.
Oh, awesome.
And we keep those on, our website now, it's poultryventilation.com. And it's probably got over, I need to go through and count, but we're well over 400 newsletters on there now. So the other thing that I'll be kicking myself if I didn't mention it is we do have an app.
Oh.
And if you have the app, it's called Poultry 411, and it's free. It's available on both the iPhone and the Android. And it has 5 calculators in there. And the one calculator that really fits with today would be the moisture balance calculator. The minimum ventilation rate calculator is there. So it basically uses the conditions that you have today in your house to help you estimate what your ventilation rate should be. And so that would be a useful tool. I like to use it to show people, if they are underventilating. And very rarely do I come across a farm that's over-ventilating. So it's just a good tool for that. And just going to help support that relative humidity, because you take into account inside-outside temperature, your outside relative humidity, your inside target relative humidity, which I'm always going to set as either 50 or 60%. And then your water usage for the day before. I always use the day before, so I know exactly how much water was consumed over the 24-hour period. And then you put in your ventilation rate, how many fans you're running, CFM, and it will tell you how many minutes, minutes out of 5, or how many seconds out of 300 seconds on a 5-minute timer that you need to be running that fan.
Oh, that's so interesting. Kudos to you guys for developing that.
Yeah, the other calculator that we've come up with that we've put into that app is a house tightness calculator. And that folds into this type of the year. We didn't really discuss that much in this podcast, but house tightness is really important all year long as well, because we've gone to this effort of cutting these holes in the sidewalls for inlets, and we want our air to come through the inlets. So it'd be nice if we had, at least, 65% or more of the air coming through the inlets, because that air is getting preconditioned before it comes down to bird level.
Mm-hmm.
If you've got less than 50% of your air coming through your inlets, that means you've got a large percentage that's coming through cracks, loose areas, maybe around the tunnel doors, the tunnel curtains if they have them, the in-wall doors. There's leakage somewhere that needs to be addressed in order to get more air coming through. And so that ties back into effective moisture control and environmental control during cold weather as well.
It's such an interesting system.
It is.
It's not just, put numbers in and forget it and walk away. This is daily paying attention.
It's management, just like it is with most agriculture, right? You gotta manage it to get the optimal results.
Exactly. Well, thank you so much for talking to me all about these topics. And I'm sure everybody who's listening is really excited to hear about that app like I was.
Okay. Excellent. I've enjoyed it.
Yeah. It simplifies things when you can do something like that. So thank you again. And I hope to chat with you soon.
Thank you.